Everybody, here is your review guide video for the Chapter 7 review. Alright, so starting out, remember there's rational expressions all over this test, so there are going to be graphing rational functions, there's going to be dividing, multiplying, adding, subtracting, solving, inequalities, all that good stuff. So starting out with the first one, we have this rational expression here, it's rational function, and we're graphing it. So we want to have all this information up here, so make sure you're reading directions. We've got an asymptote, domain, and range. We've got a graph as many points as we need. We did 8 in class, so that's kind of what I want to see. And we also have to draw the asymptote, okay? So, first of all, looking at this, we have to identify where our asymptotes are, okay? So looking at this, remember we find undefined values. So at the bottom, we got x can't equal a -1, all right? And that's going to give me an asymptote of x equals -1. And then remember the rules. So we got the degree of the top and the bottom, they're the same. So we look out front, in front of the x's. So we got a 1 over 1. So we just use those leading coefficients, make a fraction with them, and that tells us the other asymptote. All right, so that's a y equals 1 asymptote. So we need to draw those asymptotes. We got a x equals 0, or x equals -1, excuse me. Got that one. And we got y equals 1. So those are the asymptotes that are going to be kind of the boundaries for our graph. So we can get our domain and range from that. So remember, your domain is all reals except for that asymptote. All right, and your range is the same thing, all reals except for that asymptote. And it's a y cannot equal 1. Okay, from there, it's just simply an xy chart. So you put this in your calculator. Remember, if I'm putting numbers in my calculator, I need to put the top of this thing in parentheses and the bottom in its own set of parentheses to make sure that I get the correct values. And then you're putting your numbers in for x there. All right, so I have these numbers. And remember, the reason I chose those numbers is because I want to pick points that are close to this asymptote here. I want to pick points on the left and right side of that asymptote. So that's why I chose those numbers. That's at x equals -1, so I need -2, -3, -4, -5, and I need 0, 1, 2, 3. So these are the numbers that I get for those. And this is just simply putting it in your calculator to see what you get. And this one, if you're looking at these points, they're fairly close together. So you might want to do another maybe 1 or 2 points on either side to watch it move away from an asymptote. So let's graph these. We got that one, -3, 1.5, -4, 1 1/3. So you kind of see that it's going to just be going like this. Now remember, these are going to look like parabolas going in opposite directions. So we don't have to get those other points that are closer to the asymptote, but it may help. It's going to kind of curve up like that. And then below here we got 0, 0, 1, 0.5, 2, 2/3, and that's kind of the same as that last one, and it's going to kind of curve down right there. So that is the graph of that one. And I'll try to use a different color ink so you can see it a little bit better on the second one. Okay, so the second one, this is just our regular reciprocal functions that we started with. This was like chapter 7.3, I think. Remember, you can't use our rules of rational functions here because we have two things here. It's kind of separated. These were the easier ones, okay? So let's identify our asymptotes first. We know by looking in the denominator here that we get an x can't equal 0 restriction. And then, so that's an x equals 0 asymptote. And then remember we found the other one by looking at the back end. That's a y equals 1 asymptote. Okay, so remember you look in the denominator for your x asymptote, because that's an undefined value, and then you look on the back end for the y equals asymptote. Okay, so domain again, all real numbers. X can't be 0, range, all real numbers. Y can't be 1. And then let's graph those asymptotes. We got an x equals 0, I said. Okay, that's just the axis there. We got a y equals 1. So it's going to look fairly similar to the last one. So remember, we need points close to this asymptote again. If I have an x equals 0 asymptote, I probably want 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5 if I need all those values. 1, 2, 3, 4. Let's just go to 4. -1, -2, -3, -4. And the values I have are these. Oops. Correction. 2 is 0.5. 3 is 0.67. 4 is 0.75. And then we got 2, 1.5, 1.33, 1.25. Okay, so let's plot those points on the graph. I'm going to use green. So we have 1, 0, 2.5, 3, 2/3, and 4, 3/4. So that's just kind of just like on that last one. It's just that little chunk there, but you know it's going to curve down when I get close to that asymptote. -1, -2, -2, 1.5. Same kind of thing as that last one, that last side there. It's going to kind of curve down, and then here it'll curve back up. So they look like parabolas in opposite directions. Okay? So I'll get number 3 set up for you, then you can finish your graph. So we have to these are the rational expressions again, or rational functions again, because there's nothing on the back end here. It's not plus something, and there's an x in the top and the bottom. That's how I know I need to look at the different rules, okay? If we look at the one that was right above here, we got 2 things that are kind of separated there. It's not an x on the top and an x on the bottom. It's just a single x on the bottom, or just variables in the bottom of one fraction. Rational functions here have x's in the top and bottom, so we're looking to use our rules for those things. Okay? So we need to first find the asymptote. This one's a little bit harder to see, because it's not just x can't be -1. Remember, we're looking for what would make the bottom 0. So let's figure it out. So we just set it equal to 0 and solve. -1, -1, I get 2x equals -1, so we get x equals -1/2. That's my asymptote, okay? X equals -1/2. So that would make a 0 in the denominator, okay? Let's move this stuff out of the way. Now we have to look at this to figure out the other asymptote if we have one, okay? This is the degree of the top is a 3rd degree. The degree of the bottom is 1st degree. So what rule do we go by? The degree of the top is bigger than the degree of the bottom. That tells me there is no y asymptote or no horizontal asymptote. Okay? So we only have one asymptote here. So let's just have that one down there. So we just have a domain down here, and I'll show you why I didn't make you do a range on this one after we get the graph. I'll kind of show you what it looks like. Domain is all real numbers, except for x cannot be -1/2. Okay, so if we draw that asymptote like this, right at -1/2, and then you would start choosing points close to that. So these are the points that you should probably do. So if we're doing a -1/2, I have -1, -2, -3, -4, and then 0, 1, 2, 3. 1, 2.67, 5.4, 9.14, 0, 1/3. Okay, so those are the points, and this is what the graph kind of looks like. I'm just going to kind of sketch it So it'll be coming down here, and then this one, as it gets closer to the asymptote, goes up. All right, and then the other one kind of comes down here, curves a little bit, and then goes down. That's what the graph looks like. And these points right here, my negative values, don't really tell me what this part of the graph does. So you might have to do more points, like maybe like negative 0.75, or maybe negative 0.9, okay, something that's, oops, other way. We don't want negative 0.9, we want like negative 0.6 maybe, because that's really close to that negative 1/2 asymptote, okay? There will be one on the test where you're going to have to pick points close to the asymptote. Okay, because that'll help you figure out what those ends are doing there. Okay, next one we have rational function with slant asymptotes. Okay, so remember when we had to divide the top and the bottom. So first of all, we have to figure out how we know it's going to be a slant asymptote. Okay, we look at our degrees again. Okay, the top is bigger than the bottom by 1. By 1 degree. That tells me it's a slant asymptote, okay? Because we have a 3rd degree on the top and a 2nd degree on the bottom, okay? Then we have to remember rules to dividing polynomials, okay? And this is an x squared, so that means we're not going to be able to use synthetic division. We can use long division, or we can make it really easy. Remember what happens when we have a single denominator? You can just split it up between those. So we would have this. And then we could just simplify that a little bit. Alright, so x cubed over x squared right there, that simplifies just to an x. And then this one right here simplifies to 1 over x. So remember, remainders are the things that kind of look like fractions. So this is our remainder. We care about our divider without the remainder. So that's the slant asymptote. Pretty simple, right? So we have x cannot equal 0, because we can't put a 0 in the bottom there. And now we have a y equals x, slant asymptote. Okay, so domain is all real numbers, except for x can't be 0. And again, I don't have range on here. And actually, I think on the last one, all the way at the bottom, I didn't have that range. It is actually all real numbers. Okay, so we could add that if we want to. Let's see what this one's going to be. I think this one is a little bit harder for the range. But points that we need. So we do that. Let's draw our asymptotes quick. So we got x equals 0. So that's this, right on the axis. Y equals x. So that's starting at 0, 0, up 1, over 1, like this. All right, so it's just kind of cutting the whole graph in half there. So that's y equals x. That's going to be our slant. So since our asymptote is x equals 0, you probably want 1, 2, 3, 4, 5. I'm going to do a little bit closer on this one. Okay, I'm going to start at negative 0.5. And then I'm going to start at positive 0.5. And then here are your values just for checking. Let's fix that one. It's negative 3 1/3. And then for 0.5, we get 2.5, and 2, 2.5, 3.33. Okay, so this one is very symmetrical, as you can see by those points. So I'm going to save a little bit of time, just kind of draw my bottom pieces there. 2.5, 2, 2.5. There, so this is going to be kind of like this. And this is going to be the same way. that's what that one's going to look like, okay? And I don't have range in there. You don't really, it's a little bit harder with these. So you kind of see there's a gap here. So your range would have to be y is greater than something and y is less than something. But it's kind of hard to get it, so that's why I'm not requiring you to do it. You won't be required to do that on the test. Okay, down below here, there's the number crunching for the lesson. So for the review. So just simplifying rational functions. We got addition, subtraction, multiplication, all that good stuff. Okay? So this part right here is finding vertical or horizontal asymptotes or points of discontinuity. Remember, the points of discontinuity are either vertical asymptotes or holes in the graph. So I had you guys write those big words down. So it was infinite discontinuity for an asymptote or removable discontinuity for a hole. I'm not going to make you memorize that. I just want you to know how to find them. Okay? So you want to factor and cancel if you can, or factor and find excluded values. So down here, really we just need to factor the denominator. So we can take out an x, and we're left with x plus 4. Okay, from that, I can get 2 points of discontinuity, or I can get 2 asymptotes from this one, really. So I got x can't be 0 from that one, and then I got an x can't be negative 4 from that one. So there are 2 asymptotes for this one. You got x equals 0 asymptote and an x equals 4 asymptote, or negative 4 asymptote. Okay, so same thing over here. We're going to factor the denominator. So I need 2 numbers to multiply to give me 8 and add to give me a 6. So that's x plus 4 and x plus 2. Okay, so right there you can see something cancel. Looking between the numerator and denominator, that x plus 2 will cancel. Okay, remember when things canceled out? That was a hole. So I got x can't be negative 4 from that one. That's an asymptote. And then from the other one over here, I got x can't be a negative 2. And that's a hole. Okay? And then let's see if we have any other rules going on for these. So we need to look for any vertical or horizontal asymptotes. So the horizontal, those are the y equals. So looking back over at this one on the left, looking at my function as a whole, the top degree is 0, bottom degree is 2. So that means we're going to have a y equals 0 asymptote. Remember that rule that said if the top was less than the bottom? That was the second rule that we wrote down. Then we have a y equals 0 asymptote. And same thing going on over here. We got a y equals 0 asymptote because the top degree is less. Okay? So those are all the asymptotes and holes or points of discontinuity in these graphs. So down here, simplify expressions. All right. So we got multiplication and division and subtraction and addition going on here. I'm just probably going to do a couple of these because they're not overly difficult, and I can show you what they factor to, and you can kind of go from there. All right. So first one here. First thing you want to do, recognize this multiplication. So that means we just want to cross cancel first. So the 16 will cross cancel to a 2, and the 8 will cross cancel to a 1. It's an ugly one. Let's fix that. So 2, 1. And then the other way, we got 7 and 21. Those will cross cancel. So we could take 7 out of there, making it a 3 on the bottom. And then I said in class, it's easier just to kind of multiply across and then simplify. So we're going to have a 2 on the top. We're going to have a to the 7th. And then we're going to have b to the 4th, c to the 4th. And on the bottom, we don't have any a's. We got b to the 3rd. Oh, we got that 3. B to the 3rd, C to the 5th, and D to the 4th. And then we start canceling variables out and simplifying. So we got 4 B's are going to cancel, and we got 4 C's are going to cancel. There's one on the bottom. So let's just keep rewriting this. We got A to the 7th, B on top, and on the bottom we're going to have 3, C, D to the 4th. Okay? Just because remember, if you have some on the top and the bottom, you're going to cancel some out. So 8 you want to factor and then start canceling. So I'll show you how it factors quick. So you can see that a plus 2 is going to cancel. Boom, boom, and we can cross cancel between the 5 and the 10, and you get 12. Kind of works out nice. So number 9, there's a lot of factoring going on here. So first one, you need to multiply to 4 and add to 5. So that's going to be 4 and 1. And on the bottom of there, that'll just be x plus 1, x plus 1. And then the second one over here, so we see a 2 there and a 2 there. We can take a 2 out. So 2x plus 1. And on the bottom, we just have that x plus 4. Okay, so let's start canceling stuff out. So remember we can kind of cancel from the entire numerator and then the entire denominator. Just kind of look what's on top and what's on bottom, and then cancel stuff out. So x plus 1's here cancel out, x plus 1's here cancel out, x plus 4's cancel out, and we're left with just a 2. Okay, so next one here is division. So remember, division is skip, flip, multiply. So that's kind of what people remember from the middle school. You skip the first one, you flip the second one, and then it turns into multiplication. Okay? So that would just rearrange the problem to this. Times 12 over a squared minus b squared. And then you just factor. So this one down here factors to a minus b, a plus b, and then you cancel those a plus b's out, and then we look between the other diagonal. We got the 3 and the 12, so that'll cross cancel to a 4. We got 4 over a minus b. Simplifies to that. So these kind of are simplifying to fairly nice numbers. Number 11, just like one we had on the quiz. So again, that's division. I'll just show you how it factors out. So it's going to be skip, flip, multiply again. So two numbers that multiply to negative 20 and add to negative 1. That's that. And then the other one. Okay, and then we flip that. C there, the 3c minus 3, we flip it and factor. And then right there. So finish that one out, start canceling stuff. And I think we end up getting 3 over c minus 4. Okay, so number 12 here, these are those complex fractions. So remember, you're going to have to factor everything, and then that big sign right there in the middle, that's the same thing as division, right? So you're going to skip the first one, or skip the top one, flip the bottom one, and then turn it into multiply, right? So let's factor it. We got 4, oops, nope, top one is, well, we could take a 4 out, and then it becomes c squared minus 9. Well, that's the difference of squares again. All right, so the top is going to factor to this. 4c minus 3, c plus 3, over, take out an 8c, and we're going to have c minus 3. On the bottom, we're going to have a 12, we can take a 12 out, and then we have c plus 3. And then on the bottom of that one, we could take a 2c out, and we have c minus 3. So, now it's time for skip, flip, to take this one, move it to the top, and flip it. Alright, so we got 2c, c minus 3, over 12, c plus 3. And it's multiplication now. So we can start canceling stuff out. So that'll cancel with that. That'll cancel with that. We got that c that's going to cancel out there. We can cross cancel the numbers all around. So that's going to turn into a 1. This will turn into a 3. That'll turn into a 1. That'll turn into a 4. And now we can put it back together. So we'll have, we just got a c minus 3 on the top. And then on the bottom we got a 4 and a 3 it looks like, so it's just over 12. Okay? So those are complex fractions, the same as division. Okay, addition, subtraction, and solving equations and inequalities. So subtraction and addition, remember we need a common denominator. First thing we got to do is factor. Right, so we factor the bottom, x plus 3, x plus 3. And then we can factor over here, x minus 3, x plus 3. And then we need to get a common denominator, okay? We can see right here we can cancel that off and make it a little bit easier at the beginning. But let's just say we forgot to cancel that at the beginning and get a common denominator. So over here on the left, we're going to need an x minus 3, because that's a factor over here that we need. Okay, and on the right, we need x plus 3 there twice. Okay, let's put this on the top here also. And then we need an x plus 3 twice over here. Okay, we have it once there and once there. So we have our x plus 3's on the bottom, and we're good to go. So up here, we're going to FOIL that out. So x squared plus 9 is what that'll FOIL out to, right? Because it kind of looks like difference of squares, so it actually FOILed out to something that looks like that. X squared minus 3, or minus 9. X squared minus 9, and over here we're going to have minus 2x minus 6. That's what our numerator is going to look like after we multiply that out. Okay, so let's simplify that down. X squared minus 2x minus 15, that's going to be all over x plus 3, x plus 3, and then x minus 3. And then we need to look at this one more time, because the bottom actually factors again, just like we said at the beginning, that x plus 3 would cancel out. So the top is going to factor 2, x minus 5, x plus 3, and then that would cancel with one of the x plus 3's on the bottom, if you kind of see that over here. This is my denominator, and I'm just going to kind of save some space here. But x plus 3 would cancel with that one, okay? And then we'd be left with this. We'd have x minus 5 over x plus 3, x minus 3. And that would be your solution for that one. Okay, so number 14 is an addition problem, and it's pretty easy. So we need a 2 and a k minus 1, or k plus 1 at the bottom. So we need to take this one times 2. Okay, and then you can put it together. So our common denominator is going to be that 2, k plus 1. And then on top, we're going to have 8 plus 9, which is 17. That's it. 15 here. Factor and common denominator again. So it's subtraction. This factors to n minus 3, n plus 3. So that's going to be our common denominator. Okay. So it looks like in the second one here, we're missing the n minus 3. So we'll have 6n, and that negative 3 goes through there. 6n minus 3n plus 9. Okay, and then we need to take it one more step and simplify that. So this turns into 3n plus 9 on the top over n minus 3, n plus 3. And now I kind of see something going on here. Because remember, whenever we add or subtract or multiply or whatever, after we put it together, we have to simplify as much as we can. So on the top, I see that this can be factored to 3n plus 3. And then I see the bottom is going to cancel out there. So our actual answer is 3 over n minus 3 after I simplify everything. So make sure that you simplify before you're done. Okay, and then on the second one over here, 16, I see this little one that's a little bit different than this one. So remember that rule that we had to get those to be the same. They are pretty much the same, but it just looks like they're flipped around. I always want to make my variables positive if I can. So on that one, I'm going to take out a negative 1. And then I'll have m minus 5, because remember when I take out that negative 1, it just flips those around. So this is going to be that negative 1 m minus 5 is going to be my common denominator. And then it looks like we're just missing the negative 1 here and here. So that will make it a negative m minus 2 on top. And if you want to, I would probably recommend simplifying this because we can factor a negative out of the top to make that variable positive. And then we'll have a negative out front on the bottom. And then you should see, oh, I got a negative on the top and the bottom out front, so I can just cancel those out. And you're left with m plus 2 over m minus 5. Okay, I don't think you're going to have one that you have to simplify that on the test, but I just wanted you to see this little rule here, that little switcheroo. Okay, if I have a variable that's negative, I can take a negative 1 out and it flips them around. Okay? All right, getting towards the end here. So solve the equations. I'll show you what it looks like after we multiply by that common denominator and then solve it. And then the inequalities will probably solve one before I jump to the word problems. Okay, so that's over 1. So we want to take everything just times an n minus 4. It's actually a fairly simple one. Okay, so when I multiply each of these by n minus 4, the denominator is going to cancel on some of them. So let's take that back a step. From here to here, the n minus 4 will cancel. Actually, let's go all the way to the left here. So from here to here, n minus 4 is going to cancel. I'll just have an n. Okay, so from here to here, nothing's going to cancel. So I'll have n squared minus 4n. And then from here to here, the n minus 4 will cancel. I'll have 12 minus 4n. Okay, so then I see an n squared and an n. That means I'm probably going to factor, so let's put everything on the left. I have n squared, and I'll have minus 3n equals 12 minus 4n. So let's keep moving stuff to the left. So I'll have n squared. I'll add that 4n. So I'll have plus n, and I'll subtract the 12 from both sides. So I got that. So then I factor that. So two numbers that multiply to give me 12 and add to give me a 1. That's a 4 and a 3. So n plus 4 and minus 3. So two solutions are n equals negative 4 and n equals 3. Which one, if any, will ruin the equation? It doesn't look like either one will do that because we just need we can't have a positive 4 in the bottom, so we got a negative 4 there, so we're good. Okay, and the 3 doesn't ruin it at all. So, second one over here, we're going to multiply everything by a y plus 4 and a y minus 3. That's your common denominator. So if we take it to the 6, the y plus 4 cancels, we'll have 6 y minus 3. If we take it to the 2, then remember that's a negative 2, it's subtraction. The y minus 3 cancels, we have 2 times y plus 4. And then on the back end here, nothing will cancel, so we have 3 times both of those. Alright, so then you'd end up simplifying that down, and you get an answer of y equals negative 5/3, and y equals 2. You'll have to factor that to get those answers. All right, so inequalities. I'm going to take care of the first one because that'll be more like what's on your test tomorrow. So multiply everything by the common denominator. So you can see we have an x there and a 4x there. So my common denominator will be a 4x. Okay, so if we take that times the first one, nothing cancels. I get a 12x. Take it times the second one, the x cancels, so I have a 16. Take it times the last one. And remember, we can change this to an equation rather than an inequality. The 4x will cancel, and I just get a 5. So quickly, let's solve that. 12x equals 21. Yep, and then x equals 21 over 12, which you want to simplify, because we could take 3 out, right? So we get x equals 7 over 4. We need that for our final answer, okay? And then we also needed that excluded value at the beginning, so x cannot be 0. Those are the two pieces that we need for our number line. So we need those intervals. 0, 1, -1. 7/4, that's 1 3/4, so let's put 2 on there. And then we'll draw our intervals. So 1 3/4 is here. That's my 7/4. 0 is there. Okay, remember we need to check those intervals. So let's check a number here. We'll probably check a -1 here. Probably check a 1 here. And I would probably check the 2 there. Okay, so this ends up working when I put it in my calculator. This does not. This ends up working as well. Okay, so if you wanted to see some math behind that, so it's 3 minus 4 over -1 is greater than 5 over 4 times -1. So just kind of simplify that. So this is a double negative here, so it's 3 plus 4. 7 is greater than -5/4. Yeah, that makes sense. Okay? So remember, you're plugging into the original equation, and then you're just kind of seeing if that inequality makes sense when you check those numbers. So I need to say an inequality for this way, and then I need to say an inequality for this way, starting at the intervals. Okay, so that's x is less than 0, or x is greater than 7/4. That is the solution to that one. Okay, so it'll be more like that on the test. This number 20 over here has a little bit more to it because you end up getting 3 numbers to make intervals for. But we would multiply everything by 15x minus 4. Okay, and that ends up working itself down. After I do that, boom, 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 I get 3x squared minus 2x minus 85 equals 0. Then you simplify that one. Okay, I think that actually came off of your homework. Okay, so your solution when you're done, x is less than -5, or x is, actually this one, a little bit more difficult because there's odd intervals that work here. So we get 4 is less than x is less than 17/3. So we have 2 intervals that work. And let me double check on that -5 one. So -6. Yeah, that ends up working out like that. So it's a little bit harder. All right, let's finish these last few problems. So the equation z equals 30x represents a direct variation. Okay, so usually when there is just multiplication like that, straight across, that's direct variation. Look at the equation over here, direct variation right there. They look the same, okay? Second one here, we got division. All right, that doesn't look like the equation off to the right, but this is inverse variation. When you think of division, what things divide, like inverses divide, right? Can we rearrange this one to look like that? Well, yeah, you can divide by a y and you get x, or divide by an x, you get y equals a over x, right? So that is your inverse variation. Okay, so 23, this is inverse variation using the proportions. Okay, if y varies inversely as x and y equals 2 when x equals 10, so that's like your y1, x1. Find y when x equals 5, so that's like x2. So then we just throw it in our proportions there. Okay, so x1 is 10, y1 is 2, so y1 is down here. Okay, and then we have x2 up here. Find y when x equals 5. Okay, so that's the one we're looking for. So this is cross multiply. Boom, 20 equals, boom, 5y. Y equals 4. Okay, pretty simple. The direct variation with the proportions would work the same way. as you're looking from left to right, you mark the x1, y1s as you see them. They're usually going to be together. x1 and y1 will be together. x2 will be by y2 if you have it like that, okay? So we got direct variation, and again, there's three things. So we're going to use our proportions. So y1, x1, I think it's x's over y's. No, y's over x's. So we got y1 is 5, x1 is 3, equals y we don't know, over 2. So again, cross multiply. 10 equals 3y, y equals 10/3. Not a very nice number, but it works out that way sometimes. Okay, so now to 25, we're going to write an equation. We have to find that equation. So we got y equals 18 and x equals 9. We only got two things. So we're going to be using this. Y equals ax. So we do have a y and an x to plug in. Let's plug it in. All right, so a times 9, so let's write a 9a. Divide by the 9, we get a equals 2. So then we need to plug that back into our equation. Y equals 2x. So now, let's use that down here. Okay, so y equals 2x. Find x when y equals 27. So 27 is there, 2x is there, divide by 2, divide by 2. X is 27 over 2. Okay, not too bad. All right, I'll show you how to set up these last few problems. I'll give you the answers for them. So 26 is just like the one that was on our homework before. I said you should probably know how to do that. So Peter can paint a house in 10 hours, and Melanie can paint that same house in 9 hours. How long would it take if they worked together to paint a house? There's one just like this on the test, okay? So Peter can do it in 10 hours, and we're doing it together. Melanie can do it in 9 hours. How long does it take us to do it together? So that's what we're looking for. So you use the word problem to make a rational equation, okay? So multiply by a common denominator, which looks like it would be 90x, okay? And we can do it two ways. You can just add on the left and then cross multiply like fish method stuff, or you can multiply it all by a common denominator. So let's do it that way. So we're going to multiply by 90x. So from here to here, 90 and 10 will cross cancel to give me 9x. From here to here, 99 will cross cancel to give me 10x. And from here to here, the x will cancel to give me 90. Okay, so I just kind of simplify that. 19x equals 90. Divide by 19, I get x equals 4.74 hours. So they can paint a house together in a little under 5 hours. Okay. Number 27. So this is a distance kind of a problem. So we see distance. So we need distance equals rate times time. This is a very simple formula to remember. Distance equals rate times time. Everybody should kind of remember that because we've kind of been doing it for a little while. So distance that she travels very directly, and you could use y equals ax also, because I see directly, right? That's a direct variation. Distance equals rate times time is usually direct variation type problem. Okay, suppose she bikes for 50 miles. That's distance, and it takes us 2.5 hours. So that's rate, I don't know. 2.5 is my time. At this rate, how many hours would it take her to bike 80 miles? So let's figure out what rate she's going. And you can kind of do this problem with common sense. So divide by 2.5, and we get her rate to be 20 miles per hour. Okay, so now, how many hours would it take her to bike 80 miles? Okay, we want to go 80 miles. Our rate is 20 miles per hour. What's the time? Divide by that rate there, so you get t equals 4 hours. Okay, you can use some common sense to figure this problem out. It's not too bad. 28, those are the ones that are a little bit harder. Okay, and I don't think I have one like this on the test. On the retake, I think I might have something like this. Okay, but we're swimming for 5 hours. Okay, we can kind of use the distance equals rate times time scenario. in a stream that has a current of 1 mile an hour. She leaves her dock and swims upstream for 2 miles and then back to her dock. Okay? So what's her swimming speed in still water? This one's a little bit different from the one we did in class because we're going the same distance, but we don't know the time for each one. Okay? So that means we're just going to have, we're going to be solving for time. We're going to have two things that look like this. We're going to have a distance and a rate going with or against the stream, and then we're going to have another distance and a rate going with or against the stream, and that's going to be set equal to that time, which is 5 hours. Okay? So the distance, we're going 2 miles. Let's say the first one is going against the wind, or against the stream. Okay? That's going to give us, if we add those times together, so this is our rate going with the stream, and our total time that it took us was 5 hours. Okay? And then that's a pretty standard rational equation. So we multiply it by r minus 1, r plus 1. Simplify it down. So this one you're going to end up factoring and see if you can factor it. So when we get it all simplified down, we're going to have 5r squared minus 4r minus 5 equals 0. And then it looks like SMILE method. You're going to have a lot of time trying to factor that one. It doesn't factor, so then you have to use the quadratic formula. Okay? So it's negative b plus or minus square root b squared minus 4ac all over 2a. So let's plug stuff in. And we plug it in and we simplify. We end up getting this. Alright, which isn't really a nice number, so you put it in your calculator, you get one positive answer and one negative answer. We get 1.48 miles per hour. So that's how fast Lilia swims. Okay? So that one's kind of hard. I won't have anything that difficult on the test for you. Alright, but it's good practice. So that is your review guide, people. It's kind of time-consuming. It takes a little bit of time. The test is not going to be as big as the review guide. I think it's like a little bit less than a normal size of this because it takes a while to get these problems done. So hopefully that helps out. Let me know if you got questions. Good luck.